Hello students, today I am going to discuss a question from Science Exploration book, chapter Work Energy Power, Work Power Energy. That is question number 1. So let's try to solve the question. One graph has been provided for the question and it has been provided force versus displacement graph. Okay, you can see along the x-axis displacement is provided, along the y-axis force is provided. Okay, no issues on that. Question number 11, what they are telling, a 10 kg block is moving on horizontal floor with negligible friction. Negligible friction means we can consider this surface as zero friction, that means smooth surface. So friction force on the object we will consider as zero. As shown in the figure 7.37, a variable force is applied on the block in its direction of motion. Second line is also important, that a variable force is applied on the block in the direction of motion. As the force is applied in the direction of motion, that means work is positive. Second point. Third point, they are telling in the direction from its position 0 meter to 4 meter. If the block had a kinetic energy 180 joule, when it was at 0 meter, find the block speed at 0 meter and 4 meter. Does the block have negative acceleration in any portion of the motion or not? That we will consider later on. Okay, so let's solve this question. So for that I will start camera. Okay, first of all, to solve this problem, the main important key thing that is required, that is work energy theorem. You might ask, what is work energy theorem? In NCERT it is written little bit conceptual things, discrepancy is given. They have told that work done by all force equals to change in energy. Rather than saying that, I'd like to say work done by all force on an object, that is equals to change in kinetic energy. I'm repeating again. What is work energy theorem? Work done by all forces. All forces mean external force, conservative force like gravitational or elastic, electrostatic, whatever force, plus non-conservative force like friction, plus external means work done by all forces on an object. If on an object all forces is doing the work, the work done by all force on an object, that should be equal to change in kinetic energy. Okay, no issues. Now what they are telling, see, now first of all, one by one every step we will solve. Step 1, given force versus displacement graph. One thing we have to know, the area of force versus displacement graph gives us work done. I'm repeating again, this total area of work versus displacement, force versus displacement graph gives us work done. That means this area will give you what? Work done. Okay, no issues on that. But how to obtain that area? The area will be calculating like that. This is like a trapezium. What is the area of a trapezium? Half into sum of parallel sides into height. I'm repeating again, half into sum of parallel sides into height. One parallel sides, another parallel sides. This parallel side this is 4, this parallel side this is 50. So not 50, 1 2 3, this is 2. This parallel side total 4, this is 1 2 3, that is 2. So half into sum of parallel sides, this parallel side of length 4 meter, this is 3 minus 1 2 meter, 0 to 4 4 meter, 1 2 3 2 meter, half into sum of parallel sides into height. This is the height and this is what, this 50. So area we are getting half into 4 plus 2 into 50, that means 150 joule. And area gives us what? Area gives us work. Okay, so what we know, that area gives us work, so work is 150 joule. Now they're asking, now to solve any question, two steps should be cleared. What is given in the question and what is asking in the question. They're asking that at point 0, from point 0 the block starts moving to point 4. At point 0, the block had kinetic energy 180 joule. Kinetic energy formula half mv square, that I'm coming later on. Now, if kinetic energy at O, it is 180 joule, we know that. So what will be the kinetic energy at point 4? How we can obtain? By, as we have already got 150 joule work done within this system, so we'll apply work energy theorem. What will apply? Work energy theorem. What is work energy theorem? Work done by all force on an object equals to change in kinetic energy. So let's solve it. Okay. So what is the work done by all force on an object? Here we have already got from force displacement graph, that is 150 joule. That is equal to change in kinetic energy. Change in kinetic energy means what is the final position of the object? 0.4. What is the initial position of the object? 0.0. That means 150 joule equals final position, that is kinetic energy at 4 meter minus kinetic energy at 0 meter. Okay, kinetic energy at 0 meter, it's already given 180 joule. 150 equals kinetic energy at 4 meter minus 180. Minus 180 is going this side, it will be plus 180. Kinetic energy at 4, because 150 plus 180, that is 330 joule. That means if the object is starting from position 180 joule from point O, now you can say to kinetic energy at point. So we have got kinetic energy at point 4, we have got at point 4 we have got kinetic energy 330 joule, and at O point we have got kinetic energy 180 joule. Now what is asking the question? In the question they are asking speed of the block at point O and point 4. At point O, kinetic energy 180 joule. We know what is the formula of kinetic energy? Half mv square. Half mv square equals 180 joule. This first question's answer. So v square equals 180 into 2 by m. M value, mass value given 10 kg, 10 kg. 360 by 10, 0 cut, 36. V square equals 36. V square equals 36, so V equals root 36. Root 36 means 6 meter per second. V equals 6 meter per second, we got. Second, what they are telling? Second, they are telling, so speed of the block at 0 meter, we have got 6 meter per second. Next they are telling speed of the block at 4 meter. What is the kinetic energy at point 4? Kinetic energy at point 4, 330 joule. And what is the formula? Half mv square equals 330 joule. That means v square equals 330 into 2 by 10, 0 cut, 66. So v equals root 66 meter. Now here you can take some approximation, that what is approximation, that root 66, not perfect square, 8 8 is 64, it is some, so approximately 8 meter per second, approximately root 66 meter per second, 8 meter per second. So at point O, object speed we have got 6 meter per second. At point 4, object speed we have got 8 meter per second. So first two answer we have done. Now the next question. So students, you can see from this question has application of work energy theorem. By the work energy theorem, we have obtained the kinetic energy at point 4. We have obtained the kinetic energy at point O. And first of all, work energy theorem. What is the basic misconception in work energy theorem? Work energy theorem tells us that work done by all force on an object equals to change in kinetic energy, not change in energy. See, work done by all force means first conservative force, non-conservative force, external force. Conservative force, that is doesn't depend upon the path. The work done by which force doesn't depend upon the path. Non-conservative force, just like friction force. Conservative force, gravitational force, elastic force, electrostatic force, and spring force, etc. And external force means work done by all force, that is equal to change in kinetic energy. So at this portion we have the kinetic energy 180 joule. Already we had the kinetic energy 180 joule. At this portion we didn't have the kinetic energy. We have obtained the kinetic energy at this portion by the formula work energy theorem, and we have got the kinetic energy at point 4, 330 joule. From there we have shown that if at this portion point O kinetic energy is 180 joule, so half mv square equals 180 joule, so V equals root 36, that is 6 minutes per second. And at this portion kinetic energy at point O, that is half mv square is 330 joule. From this portion V equals root 66, that is nearly 8 meters per second. For the next part of the video, we'll get to know that another answer, that does it have any negative acceleration in any portion. For the time, thank you.